and on Tuesday, we did some systems of equations that we solved by graphing. Today, we're going to have some special answers. Okay, so we're going to do our special answers here. So let's look at number 2. Okay, so I have this equation here, and I need to graph it. But if I'm looking at it, it's not in a format that's going to make it easy for me to graph it. So I have different ways to be able to graph my line, right? One way to graph is I can use intercepts. All right, so I split it up. Another way I can graph my line is by putting into slope-intercept form. A third way is to use T-charts. Okay, so those are 3 ways that I can solve this problem and graph it. Pick which one works for you. My personal favorite is slope-intercept because it's less work. It's just one equation. Intercepts is easy because you use 0, but it's 2 equations. And T-chart is 3 equations. Right? So I'm going to go ahead and use slope-intercept form. Open your eyes. All right, so I'm going to take my first equation. I have 2y equals negative x plus 6. And that's pretty close to slope-intercept form. Right? If I take my list or my directions here, I don't have parentheses. I don't need to combine like terms. My y is alone by itself with the 2, so I don't have to add the opposite. But I do have to undo this operation. So how can I undo 2 times y? How do I undo 2 times y? I just said we don't have to do that because y is already all by itself with 2 on the left side. How do I undo, what is the inverse operation of 2 times y? Inverse operation of multiplication is not addition.
Mrs. Creel?
Yes?
Can I have Andrew Navarro Ibarra to the office? And his parent is here to sign something that he needed signed, so if he could come up to the office with that paperwork.
Okay, he's got it. Thank you. All right, so again, look at your list. How do I undo this? Say it again, Albert. I need to divide. It's already beyond that stage. You have to understand where you are with your equation. Okay, so I'm going to go ahead, I'm going to divide by 2. What's in front of this? Negative x? A 1, so I'm going to add a 1 there. Okay. So now 2 divided by 2 is 1. So Juan shy, we're going to let him hide. This I can't simplify, so I have a negative 1 over 2. My x tags along. What is a 6 divided by 2? So it's going to be plus 3. Okay, so now I can graph this. What is my slope? Negative 1 over 2. And what is my y-intercept? 3. Now I can graph this. I'm going to go ahead and graph it. Let's find my starting point. From 0 on my y, I'm going to find 3. My slope is going to be a negative, so I'm going to go down 1, right 2. Down 1, right 2. I'm at another point. Down 1, right 2. That's going to give me 3 nice lines there. I'm going to take my straight edge. And I'm going to graph it. Draw my line. Arrows on either end, and I'm going to label it, this is 2y equals negative x plus 6. So now I'm going to take my second equation, which is negative x is equal to minus 6 plus 2y, and I'm going to solve this one. Now this one's totally different. And what side do I want that y? Left or right? What side do I want my y on? Left or right? People. Thank you. I want it on the left. It's on the right now. I'm going to just start it out by switching all my sides. So I'm going to move what's on the right, my minus 6x, minus 6, sorry. Minus 6 plus 2y. And my minus x is going to go over on this side. So now I'm closer to the format that I want. Do I have parentheses? Do I have parentheses? No. I'm going to make this smaller. Zoom it out a bit. So I want to be able to show you this. Okay, so to solve this equation here, I don't have parentheses, right? So I'm not going to use distributive property. Do I have like terms to combine? Not really, right? So I'm going to have to add the opposite, though, because I want this 2y. Really, I want y by itself, but I got to move this negative 6. So how do I move the negative 6? I'm adding the opposite. What's the opposite of negative 6? Positive 6. So I'm going to add 6 to both sides. I can't add 6 to x, so I'm going to put it off to the side. This becomes 0, and I can bring down my positive 2y. I'm going to bring down my negative x, but what's really in front of that x? 1. So I'm going to bring 1x. And then a plus 6. All right? So following my list again, now I have 2y equals negative 1x plus 6, which is almost in the, and it actually looks a lot like that problem, doesn't it? So when I solve it, right, I need to continue by dividing by 2, right? That gives me y is equal to, I can't simplify that negative 1 over 2, so that becomes my slope. 6 divided by 2 is 3. Now look at this here, and look at this here. What do you notice? It's the same thing, right? So if I was to graph this on this line, would I create another line, or is it the same line? It's the same line, right? So where are my lines going to touch? Where are my lines going to touch? If it's the same line, I'm going to find 3. I'll go down 1, right 2, down 1, right 2, and I'm going to draw my line again. Where do my lines touch? Right? They're right on top of each other. So where do they touch? Everywhere, right? It's the entire line. Am I right? Right? Everywhere. Right? It's everywhere. It touches the entire line. No. So we're going to call this answer, my special answer, of infinitely many solutions. Right? Infinitely many solutions. Andrew, you got that written down? Infinitely many solutions. So these guys had the same slope and the same y-intercept. Okay, I'm going to write that down in parentheses here. Same slope, same y-intercept. So the line is right on top of each other, and that gives me the same infinitely many solutions. Okay? So make sure you have this written down, and this might be something that you want to put in your notes or on a note card. All right, so now we're going to look at the second special answer. All right, so I'm going to use my same approach of putting it into slope-intercept form. I'm just going to write down my first equation here. My y is already on the left, so I need to move this x. What's in front of x? 1. So in order to move 1, I need to do what step? Add the opposite. What is the opposite of 1x? Negative 1x. This becomes 0. I'm going to bring down my negative 3y. And do I want to write my plus 6 or my negative 1x first? Negative 1x. And then my plus 6. I want my y all by itself. I'm going to go ahead and undo this operation by using the inverse of multiplication, which is division, and divide everything by a negative 3. So my equation is now y is equal to negative divided by a negative gives me a positive 1/3. X, 6 divided by a negative 3 is a negative 2. So I'm going to go ahead and put my slope and my y-intercept up here above. So my slope for this problem is a positive 1/3, and my b, or my y-intercept, is a negative 2. Then I'm going to take my second equation and bring it down here so I can do the same thing and solve it. I have negative x is equal to 9 minus 3y. Now this is another case where I want the y on the left, so in order for me to solve it for y, I'm just going to go ahead and swap sides of everything. I'm not changing the sign of anything. I am just swapping sides. Okay, so my y is where I want it to be, on the side that I want it to be, but it has this negative 3 in front of it, and I also have this 9. So I'm going to use my list, and I'm going to subtract 9, which is adding the opposite, to both sides. This becomes 0. I'm going to bring down my negative 3y. And this time I'm going to bring down my negative 1x, add the 1 there, and my negative 9. And I still want to undo this multiplication, so I'm going to also divide again by the same negative 3. This becomes y. So now y is equal to negative divided by a negative gives me a positive 1/3. And negative divided by a negative gives me a positive. 9 divided by 3 is 3. So my slope is 1/3 again, but this time my b is a positive 3. So it doesn't meet the criteria of having the same slope and the same y-intercept because my slope is the same, but my intercept is different. So it's not going to be an infinitely many solution. So I'm going to go ahead and graph these two. I'm going to start on my first one. My first starting point is a negative 2 on the y-axis. My slope is up 1, right 3. So I'm going to go up 1, right 3. And then I'm going to graph this line. Ideally, I'd like 3 points or more. But since I don't have it, I can graph it with the 2. I'm going to go ahead and take the second equation and find my starting point of a positive 3 on the y-axis. And I have the same slope of 1/3. So I'm going to go up 1 and right 3. And there's my second point. And I'm going to connect those two little points. And notice something about my two lines. Now, my lines, it doesn't look like they're going to touch, and they'll never touch because they are parallel. So my parallel lines are going to give me a problem as far as finding a point where they touch. Okay, in this case, I had the same line. They were identical, so there were infinitely many solutions. In this case, there's two separate lines. They do not touch. They will never touch. So the answer is no solution, because they are parallel. And I know they are parallel because they have the same slope and different y-intercepts. So those are my two types of special problems. Infinitely many solution and no solution. Good luck.